Hello, this is Dennis with A1 Telephone Service and Repair, A1 Electronics. You can reach us on the web at www.a1-telephone.com, and you can also reach us at 618-235-6959. Today I want to show you a really cool telephone. This is Mark's telephone from California, and we could probably do about a 2-hour video on this telephone. It had some major issues going on, and there is an initial checkout of this telephone. And as you can see, there's an LCD screen here, and it's not lit. But when I go and plug the telephone line in, what you're going to see is the LCD screen light up. And so basically what you have here is the telephone line is supplying voltage to that LCD screen. And basically that type of design kind of opens yourself up for, since there's voltage in the line and it's taking voltage from the line to power up the LCD. In return, what happens is you leave yourself open in the design for any kind of crossover voltage, and so it can lead to problems. And in the initial checkout, I showed you that there was no transmit, no receive, no control over the touch tone. The touch tone functions were not being recognized by the analyzer, and so it wasn't dialing out, it wasn't receiving, it wasn't transmitting, and it had another problem. Basically, that problem was on the ring cycle, what would happen is it would seize the line after a ring or 2 or 3. There was no real rhyme or reason. It could be on any number of rings, and then it would seize the line. And basically, I talked to Mark about this problem, and because all the other problems, the transmit, the receive, and the dialing functions, we've all, that's all been taken care of and repaired on the PC board. But we were left with one last problem, and that was with when you would send the telephone a ring cycle. Basically, what happens is it would seize the line, and we had to keep rechecking and unplug it, take the power, apply power, take the power off, and keep checking it and try to locate the problem. Well, in the meantime, we have found a lot of different bad parts in this telephone. Here's the hot glue from the initial checkout. This board was loose on the inside, and it had a bunch of hot glue on the back of it. Here what you're going to see is some transistors, like 3 transistors, 2 capacitors, 2 diodes, and basically these are where we're at. These parts are where we're at in repairing this telephone. And so we were down to one last problem, and I'm still not 100% sure that it's been taken care of. So I have to recheck it and recheck. It's almost like a compulsive disorder because I'm a rechecker anyway. And so what we're trying to do is keep the telephone from seizing the line on a ring cycle and hanging up on whoever's calling. Now, I have seen some microprocessors, because what you have here is you have the main PC board here, but you also have another PC board in the housing of the keypad. So basically, this microprocessor that controls the dialing in here, I'm concerned about a privacy code. I have seen some microprocessors set up to where if a privacy code is set a certain way, if a caller calls in with an unknown caller ID, or it's not sending any caller ID signal through the line, it will simply hang up on them, and it's like a privacy issue. Well, since this telephone is from China, or it was manufactured there, basically there's limited information. So I talked to Mark, and in his booklet, most everything's in Chinese. And so basically what happens is there's no real reference to any kind of a privacy code that would seize the line and hang up on the caller, if there's no information displayed or sent over the line, or it's an unknown caller. So then what we have to do, since there's no reference to that in the instructions, we have to fall back to it's a highly likely probability that the board is failing because the board had so many problems and issues before. Now, on the capacitors here, basically I'm going to move these parts over here a little bit. On the capacitors here, on different parts of the board, we've upgraded. And you'll see this capacitor right here, which was an upgrade in one of the last final steps that we took. This electrolytic capacitor here is rated at 100 volts, and it's in the ring cycle circuit. So, and it's supposed to, deal with the AC voltage coming down the line. So we upgraded that to 250 volts. And so it was better able to keep the AC away from the DC so that there was no fluctuation on the board. Because in this board design, we also found a diode in the bridge rectifiers. There's two bridge rectifiers here on this board, and they're right in the same area as this capacitor that's been upgraded. And this diode was in the board, but it was open. And if you replace that diode with a good one, what happens is it seizes the line and never lets go of it. So what that diode was doing, the silicone diode in this circuit design, doesn't make any sense. It should not have been there, and for some reason it was installed, but it either opened later on or it was open to begin with, and if it were a good diode, it would have seized the line and held the line open all the time. So it should not have been in the design. The array of transistors on this board is designed that if any fluctuations at all are recognized by this board or the configuration of the circuit, basically it turns the telephone on. And the same thing, it should have been a momentary switch. This is the plug that runs up to the hook switch, and it's a 3 conductor plug. And basically what happens is the hook switch is like a light switch. It's either on all the time in the off position, or it's on all the time on the on position. And it should not have been a light switch type situation. It should have been a momentary switch, and that's the way this circuit is designed. If it sees a resistance, it either goes high, which is on, or it goes low and goes off. And basically what happens now is a momentary switch works like this basically. If you take a switch or 2 conductors and you swipe them together and then you keep going, that would turn the phone on, and it would be in the on mode, and then if you swiped them again, it would be in the off mode. That hook switch should have been a momentary switch and not a switch that is shorted either on or shorted off. And so when you do that, when you short a circuit with that switch, any parts of the circuit on this side of the circuit or any part of the circuit on this side of the circuit basically is conducted. And so you leave yourself open for more flaws or more situations where you can get a crossover voltage. Now, we're going to leave the switch the way it is, and we're not going to go to a momentary switch, because I have actually seen this circuit fail with the hook switch out of the circuit. Basically, I could unplug this plug that leads up to the hook switch, and if I just touched it, if I just touched 2 of the prongs, it would throw this board into an on mode, and if I touched it again, it would throw it into an off mode. So in a sense, you really wouldn't even need this switch in here, just a momentary switch. But since I've seen the board fail on the ring cycle with the hook switch totally out of the situation, that, you know, there's some kind of a fluctuation. Some AC is sneaking into the DC and causing a fluctuation, which is basically seizing the line for a second and then letting go of it. But with this last capacitor upgrade right in this area, what we get is, I'm still a little hesitant to say that the telephone is actually repaired, because although the 30 or 40 different times that we've tried to ring this telephone and in different situations, I haven't seen it seize the line and then hang up and then open up again. So I do believe the telephone is repaired. But then Mark also said, you know, this phone's going to be used in a situation where I don't have a lot of inbound calls, so it isn't going to matter anyway. So there's so many different factors to it, but I'm just the type that likes to know 100% sure what was causing the problem and what wasn't. And so basically we're at this point here where this is kind of a middle of the road, or maybe even finished up with this telephone. So what you're going to see here now is, since the line is plugged in, you're going to see that the LCD screen is actually working. And I'm going to ring the phone. So you're going to hear a lot of ringing. I'm actually going to turn the ring down. Okay, it was in the low setting. Now, most of the time it would have already seized the line by now. But since this is an ongoing issue, and there's no caller ID, because the analyzer doesn't send a caller ID signal. And what I'm going to do is I'm going to stop the ring. I'm going to go ahead and answer the phone. But then I'm going to do it again. I'm trying to get the phone to seize the line and reproduce the problem. I'm going to do it another time. Okay, I'm going to answer it. And another thing that we found, I think somebody had, you know, the seller, when Mark got this phone and he contacted the seller and let them know that he was having a problem with it, they never acknowledged him. And so since there was like 3 screws just holding on the bottom when there's supposed to be 4, I found a screw that is broke off. So the reason why that's probably broke off, and the board was loose, this board